All right, number 94. So here I'm going to, first of all, rearrange this. So 3a cubed should go first. Put this in standard form. Then 18a squared. And then the 36a. Okay. Now next I'm going to check for a common factor. And you can see, since there's not a 1 as a coefficient, or the leading coefficient, or a 1 at the end, we could probably factor something out, right? Because we don't know how to factor this otherwise, unless we're a perfect square. And 36 is a perfect square, but a is not, and 3 is not, and so we can't use that type of factoring either. So we can see that 3, 18, 36 have a greatest common factor of 3, and then with our variables, they all share an a, so we take the one with the smallest exponent, so a to the first, so that's our GCF, and we put our leftovers back inside, right? So we're just going to divide each of these by 3a, right? And you can do this in your head or on paper. Okay, so 3a cubed divided by 3a is going to be 1a squared. 18a squared divided by 3a is going to be positive 6a. And then 36a divided by 3a is going to be positive 12. All right. So now we're looking for numbers that we can multiply to get 12 that we can, numbers we can multiply to get 12 that we can add to get 6, right? So let's think about the factors of 12. We did them earlier. 12 is 1 and 12, 2 and 6, 3 and 4, and that's it, right? So which of these can we add to get 6? Well, 1 plus 12 is 13. That doesn't work. 2 plus 6 is 8. That doesn't work. 3 plus 4 is 7. That doesn't work. And we're out of options, right? So if none of these work, that means that this is prime, okay? And we don't write prime here because this is actually not prime, right? We did factor it. We took out a GCF, but this inside part is prime. So we don't do anything else with this. We just leave it like this, box it up, and that's our answer, okay? All right. So sometimes that'll happen where you cannot factor. So where you can factor a little bit, but you can't factor all the way, right? And so, yeah, so just keep that in mind and just know that not every trinomial can be factored. All right, let's take a look at 98. So here, everything's in the right order in terms of the exponents and variables. But we do have a common factor, right? 3, 6, and 3, they have a common factor of 3. And then they also share a t, right? They all have a t in common. And they're all just t to the first power, so I'm just going to bring out t to the first. So then leftovers, when I divide this by 3t, I'll get h squared. When I divide this by 3t, I'll get 2h. When I divide this by 3t, I'll just get 1. And don't forget about that 1, right? Like they do cancel out, but they cancel out to 1, so you don't leave this blank. If you start out with 3 terms here, you should have 3 terms inside the parentheses as well, okay? So be careful with that. All right, so last time when we had a situation like this, we actually factored the way we recently learned with trinomials where a is equal to 1, right? Numbers we can multiply to get 1, then we can add to get 2. But in this case, I recognize that, last time we realized that, this is a perfect square trinomial, right? So 1 is a perfect square, h squared is a perfect square. If I take the square roots, I get h and 1. And if I multiply those together and double it, I get 2h, right? And so this is a perfect square trinomial. And so that means I can just set this up like this. I can take the square root of this and put it here, the square root of this and put it here. And then whatever sign this is in the middle, that's going to come down, okay? Or whatever sign of the middle term is, that comes down, right? And so that's our final answer. Okay, remember you can do it the other way if you want. You have a choice.